Hi, welcome back to DevOps presentation series. This is Satyadev. In the last presentation, we talked about DevOps phases and build. DevOps phases, as part of that, we talked about build. Now, in this presentation, I'm going to talk about test phase of the DevOps phases. So let's go to the next slide. Now, so what is the test? The test phase will start after the build phase is completed. In the build phase, we have seen two main things. One is four main things. One is the revision control system (RCS), and there is once a trigger happens in the RCS, maybe for code check-in, then the build server like Jenkins will be notified about that, and Jenkins will get that code from build server and stores it locally, and Jenkins has got all the compilers. The build server, Jenkins is a build server, right? Basically, so the build server compiles the code, creates the artifacts like DLLs or jars or exes or whatever it is required. And once they are done, as part of that, it will build process. It will put it into an installer kind of thing, and that installer will be stored in another server called artifact server. Sometimes build server acts as the artifact server, but artifacts are normally exposed through HTTPS or HTTP or HTTPS protocol, so that it's like a web server kind of thing. So this is what we are saying. Once that installer is present, right, it has to be either put into production. It has to be put into the production. But before put it into the production, it has to be tested, right? This is where the test happens. The test phase would start after the build phase is completed. In this test phase, build artifacts from the artifact server are used to install the application in the one or more test machines. Now, there are two things here. One is one or more test machines, another is the artifacts from the build server. Now, it could be manual, it could be automatic. If it is manual, it is a continuous delivery. If it is automatic, it is called continuous deployment. That's what I told you, right? So pretty much it is. Now, why multiple test machines? I'm going to talk about it. Multiple test machines may be required based on the complexity and usage of the application. If it is a small application, you just need one test machine to test the application. It's not a big, huge thing either. It's a small web page kind of thing. Fine, you just need one test machine. However, if it's a large complex application like Amazon, you need to do several kinds of tests on that application, right? So that means there are several test machines. Each test machine, one aspect of the or one category of testing needs to happen. All those machines are equivalent into production machines, and it comes to configuration, because you make sure that you are testing whatever you are testing should be going to execute in the production. So make sure that the machines are configured as per the production. But the actual environment is going to be different. For example, you are doing one kind of performance test. You will have some tools that are required for performance. You are doing some integration testing. You need something else. Like that, you will have several other test machines. So there are two kinds of environments. One, one is test environment. Second is staging environment. Like I said, test environment means not just one test machine. It could be multiple test environments, but all of them are for doing the QA testing. So quality assurance team people performs various test activities thoroughly, and each of these test environments used for specific test category before moving to the application to staging. Once the testing is all completed, then the installer from the build will be get onto the staging. Again, is it done automatically or through manual process? Depends upon whether it is if it is automatic, means it's deployment, continuous deployment. If it is manual, means it continuous delivery. So manually deployed or the shoring or automatically, it depends upon the need, right? So so following table summarizes I have created a table that summarizes the various test categories. Let's go through them. Now, there are several tests that are there, like functional tests, non-functional tests, end-to-end tests, user acceptance tests, API tests, data tests, configuration tests, localization tests, disaster recovery, explanation. There are so many other things are also there, which I might have omitted. But let's talk about each and a little bit in detail. What are functional tests? These are the tests that actually test the actual function of the. Again, we are not talking about individual components. We are talking about the entire application. So a machine has got all the tests written for functional testing. Developers QA write the functional tests. There are two ways of testing again: testing manually or automatically. So we'll talk about that little later. But yeah, there are two ways of testing: manual and automated tests. Functional tests, when a machine does the functional testing, means it will do the smooth testing, sanity testing, unit test, integration testing, system testing, regression testing. Well, all these tests are going to be done are part of the functional testing. But as part of testing, all these going to be done may not be, because smoke testing will be done at the build level itself, right? Once the build is done, a smoke test will be done. Make sure that the build is is going good or not. Sanity testing again could be done at the build level itself, because is it really working? At high level it is working or not. That's what sanity testing. Once that sanity testing is done, unit testing again is not going to be done at the test level. It's done at the developer machine level. Or part of the build also it will happen. But they won't be done normally won't be done in the test machines. Integration testing, yes. So as soon as the installer is present, if it is manually or automatically, the installer will first go to the integration test bed. It is called integration test bed. So once the installer installs the application, the tester will ensure different modules or several markings are working together or not. So basically all the components of the application are working together properly or not. That's what so the tests are written to test the integrity of the application. Then system testing, validating entire system as a whole. In this use scenario testing, like various scenarios are working fine or not. That's what system testing means. Then regression testing. For the previous, these are kind of unit tests written at a scenario level, I would say that way. So are these scenarios are all working or not in a properly? This is where regression testing happens. Basically, system testing, integration testing, make sure that all the components are interacting properly. System testing tests all the scenarios. Regression testing, make sure that nothing is broken from the previous build. In this build, nothing is broken from the previous build. That's what the functional testings are. Basically, they all aim at the functionality of the application. Now, non-functional tests, normally these will be done in a separate machine. That's the reason we need different test machines for testing different aspects. Functional machines will be done in one test machine, non-functional will be done in another machine. Again, is it necessary? May not be. If it is not a huge application, yes, you can have both of them in one machine. But if it is a huge application, yes, it's better to have them in separate machines. Now, what are being covered under non-functional? Non-functional doesn't sound like not so important, but no, actually they are more important, because they talk about the performance of the application. The actual usage of the application is based on the non-functional. That's the reason it's good to call them as quality testing rather than non-functional testing. Anyway, so there are several tests that are happening as part of non-functional: performance testing, load testing, stress testing, endurance testing, usability testing, security testing, compatibility testing, and accessibility testing. So several things. So performance testing basically speed, scalability, under scalability under load, all these things, are tested. Load testing, is it like how much load it can take? Is it taking like 10,000 requests per second? That's what customer wants. Is it happening or not? Load test. That's what load testing is. Stress testing, just beyond normal operation capability. So what happens if you go 20? Or what happens if network is broken? Is it nicely recovering from it? Or once the network is put back in, is it really working? Or it is doing something unexpected or unwanted. So that's stress testing. Endurance testing, checking performance over prolonged periods. That's what endurance testing. Usability testing. Is it user friendly? The interfaces are good. Maybe UX team will check the user usability testing. Security testing. What if I send a SQL malformed SQL query to delete the entire table? Is it actually deleting or is it safeguarding it? Security testing. Compatibility testing, ensuring the application works across several browsers and devices and OSs. So it's done under again, all the non-functional requirements may not be done in the same machine. They could be done in, for example, compatibility testing. You want to test on Windows. Let's say you have a Java code, jar file. Want to test on Windows, Linux, and Mac OS, and then you need 3 machines, right? Or 3 virtual machines, or 3 Dockers. Need something, 3 different things, right? So basically, that's how you need it. Accessibility testing. Some certain guidelines like WCAG, like people with disabilities and stuff like that. Are they able to access without? So you have that, accessibility controls on the keyboard, right? So are these working as expected? If it is required to internationally. So these are tests that happen under the non-functional testing. Now next test is the acceptance testing. Now these actually will happen on the staging machine, which I will talk about it later. But yeah, under acceptance testing, end-to-end tests and user acceptance tests. End-to-end tests are basically similarly like system testings, similar to real-world scenarios to validate the entire workflow from start to finish. So these tests are used just before the UAT happens. So first end-to-end tests happen. So these are actually end-to-end testing and user acceptance are done by not a QA will do it, but at the same time there are going to be specialized users. They are also QA, but they are not part of the engineering team. They are part of the product team. So they know the domain well. So they test those things like end-to-end scenarios and user acceptance. So is it like, if this is what's happening in the production, is it okay for the users? That's what they test. They are specialized users, right? So that's what I explained. Like end-to-end tests, user acceptance testings are conducted to ensure that the application meets the business needs and it's ready for end users. Often involved stakeholders or end users in the test environment. So basically, like I said, there are QA team, but not part of the engineering. They are part of the product development team or customer team, something like that. Now there are some important points I want to mention here. Normally, testing of functional, non-functional, and other extended test categories done under different, like I said, different servers. Now, second note is testing end-to-end user acceptance testing would be done in staging environment along with other selective tests with productive. Sometimes in the staging, you want to test other kind of tests also. Then you use you can the UAT people, the specialized user can do those testings also. Third point is repeated tests can be automated using tools like Selenium, JUnit, Test Engine. Now QA, who does the testing like performance or functionality or quality testing, which is nothing but quality testing, nothing but the non-functional testing, right? They might want to write the scripts, but they don't want to run them manually each time. They want to automate it. As soon as the installer installs it, there could be some trigger, and that trigger will start those tests automatically. They write the test, but they will trigger automatically. That's automatic testing, right? So that needs to happen. Like Selenium is used. Selenium is something that part of the curriculum, so will be discussed towards the end of these presentations. Another thing is extraction of build artifacts from the server and initialize application of the build artifacts onto various testing machines will be discussed in the delivery deployment presentation. So extracting these things, how it's a kind of fuzzy, because unless you install the product on test machine, you can't test them, right? So that means the deployment comes before testing. However, unless you test it, you don't want to put it in the production, right? So it's like a bit of which is chicken or egg, right? So but yeah, deployment and delivery when it comes to the software, it's for the customer, right? It's production. So that's the reason it is taken as a last step. But the important point to note is, unless you install or deploy the product into the test machine and staging, you can't test them, right? So deployment does happen before the testing. But even after testing also, there is deployment which is into the production. I think that's what it is. Now, there are other text extended categories, which like API testing, which validates the functionalities relevant. When the tests are used if application is a web-based API, these kind of tests are used. Basically, security of these, all the endpoints are working fine, request response formats are good, authentication and error handling is being done correctly or not. All these comes under API testing. And data testing, database testing, basically checking data storage, integrity, ETL testing, ensuring data extraction, transformation, loading, all these things are happening correctly. These are for the data integrity and stuff like that. Configuration settings. So, for example, certain applications are very highly configurable. Are all these configurations working properly? For example, the software in rockets or the artillery used by military things, right? Like so they working correctly or not for different different configurations. So this is being done in the configuration testing. Localization, let's say application is like used across the world, not just one country or one place. That means for in India, it should be appear in Hindi or Devanagari. In US, English. In China, it should be in Mandarin. So something like that. For the language specific things should be tested in the localization international testing aspects. Disaster recovery. If something crappy happens, is it recovering properly? Network is gone, hard disk is gone, some sort of in a database get disconnected. All these things are tested in disaster recovery testing. These are all required based on the application. Some applications they do require, some applications they don't. So that's the reason I put it under extended test categories. But for slightly larger applications, yes, these are all required. For smaller, may not be. Exploratory testing. This is something interesting. Testers freely explore the application to uncover defects without predefined test cases. There won't be any test cases, but testers play with them. Like they bang several crappy inputs. They don't have any plan or anything. They type something keyboard. They pull the network. That these are all called exploratory testing. So they don't have predefined test cases or anything like that. So they also will be done on these things. So I think that's pretty much about testing. Again, deployment talks about installation of the application on testing machines in the next presentation. But yeah, I think that's pretty much about for now. Thank you very much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.